Hi, I'm Colin. In this module, we're going to briefly revise the definitions of the sine, cosine, and tangent ratios that are based around a right-angled triangle. Your first exposure to trigonometry in early high school should have involved a right-angled triangle. Here's the right angle, and let me label one of the other smaller angles theta. Now recall that the longest side of the right angle triangle is called the hypotenuse. Let me label the length of this side h. The length of the side that is opposite theta, we'll call that O. And the length of the side that is right next to theta, that is adjacent to theta, we'll call that A. Now, it turns out that if you look at the ratio of O to H, that is, if you divide the length of the opposite side to the angle by the length of the hypotenuse, then that number is so useful in maths, we give it its own special name. It's called the sine ratio of the angle theta, and is written like this. And if you look at the ratio of A to H, that is, if you divide the length of the adjacent side to the angle by the length of the hypotenuse, then that number is also quite useful in maths. We give it its own special name. It's called the cosine ratio of the angle theta, and is written like this. And finally, the ratio of O to A is quite important too. That's called the tangent ratio of the angle theta, and is written like this. Some people like to remember these ratios using the acronym or lingo SOHCAHTOA. This stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Now, there are buttons on your calculator that work out for you the sine, cosine, and tangent ratios of any angle that you choose. And don't feel intimidated by the strange decimals the calculator throws out at you. Just remember that you are calculating the ratio of two sides on a right-angled triangle. One very important thing to be aware of is, since theta is an angle within a right-angled triangle, the definitions of sine, cosine, and tangent only make sense for angles between 0 and 90 degrees. In fact, you might be able to visualize the situation at 0 or 90 degrees. If the angle theta is 0 degrees, the hypotenuse would collapse onto the adjacent side, and you would not even have a proper triangle anymore. And if the angle theta is 90 degrees, then the hypotenuse would end up being parallel to the opposite side, which means they would never meet, so you would cease to have a triangle also. This is problematic because we would like to be able to define the sine, cosine, and tangent of any angle, those bigger than 90 degrees, those bigger than even 360, and even those that are negative, whatever that means. So in higher level maths, it turns out that sine, cosine, and tan are defined using a circle instead, and this will be covered in a later module. Alright, see you next time.